Okay, so hey guys, welcome again, and let us start with today's Leetcode daily challenge. Let's see what we have got today. Okay, long time no see of a hard question. Today, finally, we have a hard question. So, maximum number of points from grid queries. So, we are given a m by n integer matrix grid and a queries array of size k. Find an answer of size k. Answer array बताना हमें of same size k such that each integer queries I you start in the top. For each integer in the queries I, you start in the top left cell of the matrix and repeat the following process. And what the process says is that if queries I is strictly greater than the values of the current cell you are in, then you get 1 point is if it is your first time visiting the cell, and you can move on to any adjacent cell in the following direction, that is up, down, left, right. Otherwise you do not get any point and you end this process. Okay, so see, if this is the matrix, first query is 5. So for 5 we will start from this one, like the top left corner, and we will see if 5 is greater than this value, then we will add 1 to the count of this answer of this particular index 1, and then we will go to any of the four direction and check if it has also smaller value. Yes, it has. Add 1 to the answer. It has any, then we go to any other direction. So 3, it also has values less than. Then we go to this. No, we do not have a value less than the what less than 5. So we do not count this. But for 3 there is a value in its up direction whose value is less than 5, but this has already been counted, so we move further. For 2, what are the values? 3, 5, 1, 2. So we got here, it is already been counted. Then we go here, 2 is not counted yet, so 2 is one more value and 3 is one more value, and then we go to any other direction, we do not get an answer. So that's where we end. See, what the thing is that if we go to 5, then we have to end this process here, and the answer will be only 3. After this 3 we have to go to 2. If we go to 5, the answer will be ending here, and that will not give us the correct answer, because the answer is for this value is 5. There must be 5 values starting from there in all the direction which are smaller than 5. Otherwise, if you go to any value which is equal or greater than the 5 or the query value, then we have to end the process there, right? So what concept can we apply here to find the answer? See, first thing is, out of the four direction we have to find the minimum value. So extracting the minimum value out of all the directions, we can use the min heap for that, because wherever I see where I have to extract the minimum value. See, the thing is that we have to find the less than 5 value, but we will consider minimum, where that won't make a difference. So we will count it first, and we can take a priority queue, actually a min heap, so that we can store all the values which are less than that, and we will only count only those values which are less than 5. Okay, rest we will not go with. So but the thing is that we can only visit that element once, after that it won't count. So when we go to 6, the next query value, um, we have to make the visited array again null or 0 completely, and then we will start with it again. But will that be optimal to make that visited array again 0 and then starting all over again? I don't think that will be optimal, because yeah, obviously there must be some way. Like, see, okay, there's one thing, that if 6 is greater than 5, then whatever answer was there for 5, because in every query value case we have to start from top left. That's done. That we have to start from here only. If the value for answer for 5 is 5, then answer for 6 will be something more than that or equal to it, because it cannot be less than that. So whatever answer we have for 5, 6 will have answer more than or equal to it. So this value will already be answer of 6. Then we have to check other things, that can we go somewhere else which is smaller than 6. Yeah, now 5 and 5 and this one can be added now to the answer. So 3 more. Okay, 5 was already there, but for 2 the problem comes. Okay, so for that case, if we have this array sorted, then it will give us a edge. And what edge it will be is that if we find the answer for 2 first, it will be 1 only. Then answer for 5 will be this answer, two's answer plus some other values. And then answer for 6 will be answer of 5 plus some other values. So that will give us actually advantage, that we do not have to reset the visited array again and again, and we can work with the same thing, right? So let's firstly make a answer array vector and answer that will be of same size, that is queries size. So it is k. So let's take it as int k is queries dot size, and that will be size of k, and initially all values are 0. Okay, because we are going to sort this queries array. Okay, we are going to sort that, and after sorting it we have to return the answer in the same order. Okay, as we have this order, so we have to maintain the order. So that's why we will make a vector of pair, which will be int, and int means value and its index, so that later we can have this answer in the order we have. Okay, so we will have this temp query, something we can say. Okay, and it will be k size. Now let's fill the array with this, so 0 to k I plus plus. What we can do here is that temp q dot push back a pair, which will be value and index. Okay, value and index. So queries, yeah, queries I, and the index of it, which is I. So in that way we can return the answer in the same order. Okay, so that thing is done. Now the next thing is that we sort the queries array. So sort queries dot begin to queries dot end. Oh, yeah, we sorted it. Now the next thing. Okay, just a second. Fine. So now we have this queries array sorted. So firstly we'll find the value for the shortest one for 2. Okay, then we will find answer for 5, then we'll find answer for 6. So let's form a visited vector. That will be a 2D vector because that's a grid. So int vector int, that will be visited, and the size is basically n. If n and m are given, n by m, and n are not given, so yeah, we will find that. So int n is equal to nums dot size, that suggests the rows, and m is equal to nums 0 dot size, that suggests the number of columns. Visited size n, and vector int size m, initially everything is -1. Fine. Now let's make the priority queue, and we have to make the min heap. So what will be stored in that min heap now? That's the question. Okay, what will be there in the min heap is basically the value of that cell, and the row and column means the coordinate of that cell, correct? So we have to have a pair of integer and a pair which will contain int and int. Okay, that thing that we can take, and now we'll do this, correct? And we will do greater do this, fine. And we will add the, this is correct, right? uh, pair int. Okay, this is actually wrong, and we have to do it here. Perfect. So now let's push the first element in the heap, which will be the first element. So pq dot push, that will be a pair, will be of grid 0 0, and a pair of its coordinates, that is 0 and 0. Okay, now we will start with this. Our queries array is already sorted, fine. We make it visited. Now let's iterate through the queries. It is sorted now. That is k. So k I plus plus. We will take the first element, that is queries. So we will go through this min heap until it's empty, and we'll do what? We'll compare the min heap stop element, the min heap stop elements dot first, that will compare if it is less than the query's value, that is this value q1. Okay, qi dot first, because second is the index. Okay, if it is less than that, then we'll have a counter, obviously. Let's make a counter here as 0 initially. If that is the case, we have got one answer, count plus plus. And then we will do what we will do is we will go in all the 4 directions. Okay, so current coordinates are what? Current coordinates are pq dot top dot second dot first is the x coordinate, and pq dot top dot second is the y coordinate. Now we have to go in all the 4 directions for this. So for the directions, let's take 2 vectors, or we can say array, that is x direction vector, which will be 0 0 1 minus 1. For we will make combinations. Okay, and then to y direction will be, if you know about that, that will be, obviously, if that is 0, that will be 1, that is 0, that will be minus 1, that is 1, that will be 0, and that is minus 1, that will be 0. So we have all the 4 directions here. So we will go through all the 4 directions. Before that, we will pop the current element as it's already been used. So for int j 0 to j less than 4 and j plus plus. We'll go on all the 4 directions, and visited of new coordinates. What will be the new coordinates now? So new x will be equal to x already, which is, and plus x dir j and int new y will be equal to y plus y dir j. Okay, in all the four direction that loop will cover it. And if that element is not visited at these coordinates, so if grid new x new y is equal to uh, what is it, -1, right? If they're -1, they're not visited, then we'll make them visited now. Oh, sorry, we have to check about visited. Okay, not great. So if visited of new x new y will be 1, means they are visited, and we will push them in the priority queue. That will be the value at these coordinates. The value at these coordinates, and the second will be a pair of the coordinates itself. Fine. So after that we have done this. See, once we reach the end of this, what will be the value of the counter? Let's try for it for 5. Okay, for 2 we'll start at this. Initially this is pushed in the uh, priority queue. We will see if this is less than the priority queue's top value. Yes, 2 is greater than 1, so we'll go inside, counter will be increased to 1, and then we'll go to its coordinate as 0 0. Then we'll go to all the four possible directions fit, but we cannot go to the left or to the top of this, so we have to check the validity of this new coordinate we are having. So we can write a function here that is valid. What is valid? And then validity of this new coordinates, so new x new y and n and m will pass. So let's write the validity function. So it will return a boolean is valid int x int y int n int m. So we have to return only if x is greater or equal to 0, y is greater or equal to 0, x is less than m, and y is less than m. Okay, that will give us the validity. If the new coordinates are valid, so for 2, these two coordinates are valid, 2 and 2, then we will make them as visited and we will push them into the priority queue. So the priority queue will make the smallest in the front, but they both are equal, so it doesn't matter. Then we'll go to again to the while loop. Is the top value of the priority queues first is less than the query's value? No, it's equal to query's value. So we will end the answer here, and we will do what? We will assign in the answer array our which index will be equal to the counter. We have stored the index here. Here, this is the one. So q I dot second will be equal to the counter. Now we will go for the next value of query, that will be 5. For the 5 counter value is already 1, because this value is already counted and it's visited. These two are already in the priority queue, so we will go with this 2, any of the two. The answer is perfect. 5 is greater than 2, so counter will be increased. What are its coordinate? Its coordinate are um, first row and 0th column, so 1 0. Then after 1 0 we will go to all the possible directions. These two are the possible directions. We will push them in the priority queue, but after pushing them into priority queue, 5 will be at the last, because at the top of the priority queue 2 is there, because this 2 is eliminated, it's popped. This 3 is here and this 5 is there, so 2 and 3 will be counted in that. Okay, so then we will go to this 2. This 2 will be added to the answer. Then for this 2, what are the 4 directions which are not visited? This is visited, this is visited, this 3 will be added. Now in the priority queue the elements are 3, 3 and 5. Okay, so for this 3 will be increment the answer by 1. So answer is now 1 2 3 4 is the answer now. Okay, 4 is the answer. And yeah, 4 is the answer. Then we will go to this 3. Again, for this 5 will be becoming the answer. Then after that, 7 is there in the priority queue. This 5 is there in the priority queue. Because of this 3, 7 is there. So 7 and 5 are in the priority queue, but are their values, there is the 5 will be on the top. So is equal to 5. So we'll end the process here. Answer for 5 will be 5. And it will be on the right index due to this thing we have done here. And after that, 6 is the one. So for 6, 5 and 7 are in the queue. This 5 and this 7. Okay, so this 5 will be resolved, will be added to the queue. There is nothing left which is not visited in all the 4 directions. Then we'll go to this 5. It's again added to the answer. 7 is the answer now. Then 1 will be added to the priority queue. 1 and 7 are left. So 1 will be added to the answer as it is smaller than 6. So answer will be 8. And only 7 is left, so it cannot be processed because it is greater than 6. So that's why we will exit out, and this answer will be counted, and we will return the answer. I think that should work. Oh, it's not nums, it's grid actually. So it's temp queue, not queue actually. So yeah, and here we also have this now. Okay, so we have got a wrong answer, that is 0 0 0. Okay. Okay. After this while loop we do so. While priority queue is not empty, and pq.top.first is less than temp qi dot first. So why is the count? Why isn't the counter incremented? Because visited 0 0, grid 0 0 is being passed in it. So I don't think we are even entering this while loop. Why aren't we entering in this while loop is let's check out. Is it entering inside it? Let's see. Okay, no, it's not entering inside the while loop. And why isn't it? Then we can see if PQ is empty. Then we will find the answer for this. What's the value of this? And then we will find the answer or value for this. Perfect. Let's run this. Okay. Wait. Yeah. Okay, so when we enter in it, pq.empty, it's not empty, it will return 0. Perfect. 1 is the value for pq.top, and okay, temp qi is for first is giving 0. Why is it? It should not do this. Okay, it's size is already defined, so we cannot push back here. Okay, we should do this instead. Yeah, that should work now. Okay, let's remove this. Um, Fine. 0, 1, 5. So 5 is greater than 1. Okay, so answer is coming to be 5, 8, and 8 again. But it should be 1. Okay, okay. So by this is clear that PQ dot top is 1, but it's not sorting, okay. Okay. Okay, we are sorting the queries, not the temporary queue. Okay, fine. And we are not using the queries then. That's why 5 is still at the top of the array because it was here. So now it should work fine. Perfect, it's working fine now. So we can remove this and we can remove this. Now let's see. It should be returning just the perfect answer. Okay, what happened here? Yeah, correct. Let's try to submit this. Perfect. So, yeah, this was the question. Really good and tricky question, but simple if we break it down in piece by piece. Okay. We don't have to think too much. We just have to think about the next step. Okay. So what we did here was that first thing, the intuition is simple that we need to have visited array because we can visit every cell only once. We can count the answer from every cell only once. Then we need to find the answer for the query values one by one, and the values which are greater than less than the query value, strictly less than the query value, are only counted in the answer. So why don't we do this? That let's find the answer for 2. The answer for 5 will be a superset of answer of 2, and answer of 6 will be a superset of answer of 5. Means the answer of any query value is a superset of answer of all the queries value which are smaller than that. So answer of 6 is actually the superset of answer of 5, answer of 2, and then maybe some additional values for 6. So that's why we sorted this thing. So to find the answer for 2 first, and then for finding the 5, we don't have to make the visited array, reset it again, like again to -1, and then filling it all over again from the top of this. And this is because we don't have to visit some values again and again. So that's why we did this. And that's basically like visiting a value only once, not again. We are visiting this one, even though we have to start with one every time we find an answer for a different query value, but we are only visiting it once it's visited, then it's not again added to the priority queue, and we are only visiting the whatever in the priority queue, whatever at the top of the priority queue. Okay, so this is the most optimal approach I can think of, because the time complexity will be so much good, because we are only visiting every element only once, not again. Okay, not again, because we are checking it here. If it is visited, then we won't be watching it again. If it is not visited only, then we'll be adding it to the priority queue. And the priority queue is a min heap, so that's why it will store the minimum element at the top, and we will process that. If in the priority queue the minimum element is greater than the query value, then we don't have to look for rest of it, we can end the process here. So that's why the min heap or the priority queue is useful here. It's too useful here because whenever there is something like finding the or extracting the minimum out of uh, any values, min heap is the thing we should look out for, because that will give us the best thing. In O1 it will give us the minimum element, and also the insertion is also login, so that's the best thing we can do. So that's how we do this question. Pretty good question, time taking, time consuming. Um, But if we go step by step, then it's not really hard actually. So that will be it for today, and a really good question to do. So that will be it, guys.